I should put everybody on the screen that way. Weird. Oh, okay. All right, that worked. All right, we're live. I think. What am I doing wrong? I think it's all working. Okay. So what are you going to do for your hiatus? Anybody?
Keep writing.
Keep
Do more
writing?
writing.
Yeah.
Write about all the things. I don't really go on hiatus though.
Well, so I don't either. Like, the only thing I do is don't have to make my way to a high-speed internet connection every 2 days to do a broadcast. Like, I can do things that I can be away for a weekend, or I can go visit friends. I guess, of course, now, we don't get to do any of that.
I've successfully worked where I only had internet 1 hour per day. Like we would go in town to the library.
Yeah.
So we would do all our uploads, then download all our research, go back home, do all the writing, then come and upload everything.
Yeah.
So it is possible.
Yeah.
You strip out all the social media and all the other stuff that just like eats your time.
That doesn't sound like such a bad thing.
It's not really.
Yeah.
It forces you to be productive, actually.
Yeah, exactly. Yeah. It's funny. Like, we've been doing this now for more than a decade, and it's all, you always feel guilty. Like, I'm sorry that I'm not going to do this every single week for every single year forever.
Freelancing, there's a lot of other people ready to take your place if you don't want to do it. So you feel like you have to be there.
Yeah. Zaffan saying Starlink leaves you no excuse. That is true. So the big news, and I revealed this on Monday, is we're actually moving. So we sold our house and we're moving. So we're moving out of the city to a rural property, and rural, like, we don't have electricity, water, or septic. We're just living in a trailer. So we should have electricity in about 2 weeks, and the Starlink, we know, works like a charm, because we've hooked it up to our car, and then we run the alternator off the car to be able to actually run the Starlink for 5 minutes and go, yeah, it works, and then turn it back off because we don't want to leave our.
You're saying it's a bit of a power hog.
It's a bit of a power hog. Yeah, I haven't figured out a way without just running a generator to run it. So that's going to be, we're trying to get situated, but in the fall, it's going to be a very rustic experience. I gotta say, like, I could very well be doing these shows from the trailer. Yeah. In the wintertime. Yeah.
Winter's coming.
Yeah. And then we're actually building the studio first up there. So and we're going to live out of the studio, and then eventually, when we can afford it, build a house. So
you build the house around the studio. Interesting.
Yeah. Well, they're two separate buildings.
Oh, okay.
Yeah. Nice Fraser. Set up a solar farm and mine crypto. In Canada? I don't know.
That takes a lot of power too.
Yeah. No. We're planning to live off the grid permanently now. No, we're not going to live off the grid. Well, we are, I guess. No, we're still being connected to the electrical grid. They just haven't connected it to our house yet. So anyway, that's the plan. I'll keep you all posted, but it's gonna get a little weird when Carla and I are gonna find out. Now that my children are grown up and ready to hit the road, I'll find out if we can handle living in a trailer together. We've done a whole bunch of weeks and weekends up there already, and it's great. We love it. It's very quiet. Is there geothermal in BC? No, really, probably. I don't know. We don't do geothermal though.
You need a nuclear RTG.
Yeah, exactly. Yeah, that'd be great. Yeah.
For like 50 years.
Yeah. No, all the power most power in BC is all just, we call our power hydro. So, like, I get my hydro bill, which is actually my power bill, because it's all off of a dam.
I didn't know that, but I just started watching Kim's Convenience, and they're talking about hydro bills, and I just assumed they meant water. So that clears it up. Thank you.
Right. That would be your water bill. But we don't pay for water bills because we have so much water. But we're about to start doing that.
Got it.
Yeah. And we can't do wood stoves either in this area because of the smoke pollution. So the government is asking everybody to get rid of their wood stoves because they're awful. Like, you walk around in the city in the wintertime and everyone's got their wood stoves and it's just choking. It's
the village we go to in Spain is like that in the wintertime. The cloud settles back in when there's an inversion layer, and it is pretty smoky, actually. It's fun. I like having a wood stove, but it gets very smoky.
No, I will never own a wood stove. Never. I grew up with a wood stove. It was my job to light it every day. Never. No. I just want to flick a switch, have the heat pump come on, call it a day. Yeah, I don't even want a fireplace. No. I know, like, I've just like sucked all the romance of living out in the forest away as I am connected to.
I enjoy my fireplace.
Yeah, I like building a fire in the morning, but still.
Did you grow up?
Yeah.
Oh, no.
Doing a fire
I live
every single day?
Oh, I'm close to the equator. Fires are deep winter.
Yeah, I guess so. Yeah. In Canada, it's a matter of life and death. Okay, I guess we've reached the 5-minute mark, so let's actually do the show part. Okay, back to me. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, June 16th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about new information on the Chinese Zhurong rover, new Naked Eye Nova and Hercules, the mystery of Betelgeuse solved again, and a strange blinking star near the heart of the Milky Way. Joining me this week on my screen, I got Dave Dickinson. Hey, Dave.
Hey, here in Norfolk, what I have streaming in the background is China's imminent Shenzhou 12 launch going to their new Tianhe space station. Tianhe is to say it right.
Tianhe, yeah.
Core space station. This is the first crew going up. It's going to be launching right after we get done the weekly space hangout. So I thought it's live streaming on their state-run TV.
Sorry, I got that wrong. It's Tianhe.
Tianhe.
Huh.
It's like the E's kind of silent.
Yeah. Like that.
So it's all things China and space flight recently. So
that's awesome. That's cool. Well, so I guess I'll watch your television while you're watching your camera, and I'll let you know if something happens.
Very cool.
Do they know when they're going to launch?
9:22, I believe, Eastern time. So that's like 22 minutes after we get done at the next top of the hour.
All right.
So the launch isn't happening during, but immediately after the space hangout. But it's cool they're live streaming the whole thing.
And I don't think I've ever seen them do this before.
They've done it with some crewed launches before. Yeah, but it's rare China live streams. They live streamed their Mars launch, I believe, too.
All right. Awesome. Well, Jayo. Okay. We got Dr. Moya McTeer. Moya.
Hi, Fraser. How's it going?
Good. Anything interesting happening?
Good.
What are you doing? What's going on?
No, I don't have anything streaming in the background.
just a blank void.
Yep, I'm in my phone booth because that's how you have to do these things in Manhattan one-bedroom apartments.
With all of the fire trucks and people outside.
Mm-hmm.
Yeah. All right, and we got Alan Versfeld. Hey, Alan.
Hey, Fraser. Cold today, sitting in South Africa at 2:00 in the morning, but it's worth it to be here.
That's right. It's winter for you.
Yeah.
And we're all upside down to you. You got it right set up.
No, it's strange. You guys don't even have a Southern Cross. I can't imagine, but I suppose you have other benefits.
That's right. We have galaxies. That's what we've got.
One day I'll go see some.
Yeah, exactly. All right. Now, before we get into the special guest portion of this week's episode, I just want to give a huge shout out to our good friends at the Weekly Space Hangout crew. These are our friends, our fans, the executive producers. Really, they call the shots. We are in their debt. But if you want to be a member of this amazing community, go to wshcrew.space, and they'll give you access to all of their behind-the-scenes information, and you too can become an executive producer of this show, bring on the guests that you want to see, and really participate in the future of this show. I make no decisions. I literally just show up and do my part of the work. It's the Weekly Space Hangout crew, which are the ones that are really calling the shots. So if you want absolute power, go to wshcrew.space, and then you just get to tell me what to do. All right. Speaking of special guests, we have Ashley Walker with us. Ashley, welcome to the Weekly Space Hangout.
Thank you for having me. Thank you so very much for having me.
So the question I always like to ask people, who are you? What do you do?
Having the same issue that Moya is currently having with fire trucks going through.
Oh, yeah, I hear that. This is great. You must live in some city.
The exact same issue. So I am a planetary astrochemist and science communicator. I am an incoming PhD student at Howard University in the Atmospheric Sciences Department, where I'll be continuing to specialize in the chemistry of planetary atmospheres. Hopefully everyone can hear me.
Yeah, it's fine. It's fine. We've had worse. So what is an astrochemist or planetary astrochemist? Is that right? Did I get that right?
Correct. So astrochemists, whether planetary, some do galaxy clusters. So what we look at is the interaction, the chemical interaction between molecules within space, whether it's on comets, whether it is in planets, moons, exoplanets, galaxies, the interstellar medium, anywhere where we know that there is some sort of chemical interaction going on, that's where we are.
Right.
We're going where the party is.
Right. And specifically, you've really focused a lot of your interest on Titan. Why is Titan such an interesting world to follow?
Titan is, to me, one of the best things that ever happened to the solar system. So I am very passionate about Titan. I'm very biased, I will be honest.
Yeah.
However, Titan is very unique and it's very, very similar to Earth. And so what we want to know more about it, because this can give us clues about what happened in early Earth versus what's happening now. So it's very, very thick. It's hazy. Titan can be a real live jerk. Now, let me be clear. Now, we've been trying to look at some stuff, but it's been a jerk. So I'm really, really excited about everything that's going on with all these new space missions going on. So we want to understand a little bit more about Titan, its thick haze, its upper atmosphere, its lower atmosphere, whether it has H2O water there, or how it continues to rain methane.
So, I mean, we know that like back in the day when the Voyagers made their way through the Saturn system, they got those first glimpses of Titan, and they weren't able to see anything because of just this horrible hazy atmosphere. And then it wasn't until Cassini came along with much better instruments that it was able to peer through this atmosphere. So what do we think at this point the atmosphere of Titan is made up of?
So we do know that it has a bunch of complex organic chemistry. What we don't know it yet, because we'll learn with Dragonfly about what is it composed of. So we do see certain traces of like methane and ethane, like we've been seeing, but until we get Dragonfly launched and we get it to Titan, we'll actually know what it's actually made of. And so we know that we can't breathe there. We know that,
right.
Like, okay, you get there, okay, you're going to need a mask. That's cool. But the coolest thing, well, that's not cool, but unfortunately, that's space.
Horribly coldest thing. Yeah.
Exactly. Extremely cold. But one thing, though, if you take two cardboard boxes and put them on your arms and flap your wings, you can go ahead and do some Mortal Kombat moves, which is really cool, which I think is amazing.
Right.
So
right. So this idea that Titan has a very thick atmosphere, thicker than the Earth's atmosphere.
Exactly.
And yet lower gravity, and so you could fly around under your own wing power should you want to, which I do. Yeah.
I think everybody would.
Yeah, I think everybody wants to take a crack at that. Yeah, it sounds amazing. So then, but I guess, it's interesting, like just this idea, like Titan has been fairly well studied by Cassini and Earth-based telescopes. And yet, what you're describing is that we really don't know very much about what that atmosphere is made of, only that various molecules are present. So what would it take? I mean, you talk about Dragonfly, and we've done whole episodes on Dragonfly. What would it take to really get a sense of what that atmosphere composition is at different altitudes?
So we've studied different. So we took different instruments that were on Cassini. Let me get it correct. Yeah. And it helped us understand how similar it is to Earth. So we're looking at our own models, and then looking at Titan and looking at the two comparisons that help us look at the different altitudes that's there. Mm-hmm. So just like we have a stratosphere here, they have a stratosphere there. And so we're looking at those different things, and that helps us understand the materials as well. So when we look at our rain, the haze out rain that we have here, we look at the haze out rain that's there, that is produced there. So that's something that is giving us more hope about Titan.
Right. And I guess, I mean, I'm sort of imagining like at one level, you've got this world that has atmospheric density, has gravity, has gases that are surrounding it. And so you're going to get different layers and different densities. But at the same time, the strange thing about Titan is that everything is almost shifted one level over. While the mountains are made of water, the oceans are made of methane, the rain is made of methane, and so on. So what impact does that have, do you think, on the way the atmosphere is going to interact with the planet? Will you have, or I'm going to call it a planet, will you have the same kinds of hydrological cycles that we have here on Earth, but still shifted over one notch?
Right. And that's something that we're also going to study, because we're also going to study they're going to study. I'm standing like I'm still there. But
you'll be studying it. Just stay in the game. Right. You'll be there. Yeah, it's going to happen.
But, we're still looking at it, the sand and so on and so forth. So that's something too, as we're continuously comparing those things, and that trying to understand more about its cycle is helping us by, again, looking at how we have everything here. And also not just, here, the looking at Earth and Titan also helps us for exoplanets as well.
Right. So it's 2035 or whatever. Dragonfly's arrived at Titan, is buzzing around in the atmosphere of Titan, which again just sort of sounds like a fever dream to me, that's a thing that could actually be happening, that a nuclear powered helicopter is going to be flying around in the atmosphere of Titan. Yes, please. What would be a discovery? What finding are you going to be most interested in seeing come back from Dragonfly?
The chemical composition of its haze. Because that haze has given us so much problems, and it hurts my heart.
Yeah.
I want to see what is the chemical composition of the haze.
And what does that mean? What kinds of outcomes what would that tell you, do you think?
It'll tell us a lot about the formation of Titan. And it'll also tell us a little bit more about its evolution. So it'll tell us where it's going. Also, it'll also inform us about its clouds and upper atmosphere too, and also the precipitation going down as well.
I mean, you mentioned this early on, and I've heard this quite a few times, that the atmosphere of Titan is very similar to a primitive version of the Earth, with the various hydrocarbons that are in the atmosphere. But that also seems really weird to me, because it's so cold, it's so far away from the sun. As I said, the mountains are made of water, the rain is made of methane. And so how is that similar to a primitive Earth?
So primitive Earth was it wasn't fun. It was not pretty. It was not cool at all. It's nothing like we think, right?
Yeah.
Because most people just think of dinosaurs roaming around and all these amazing things, but we're going to go a little bit prior to that, right? So it was very little oxygen at that time. it was very little, almost of everything. So it was not what we expected to be.
Mm-hmm.
So we use certain instrumentation that helps guide us to understanding more of a primitive Earth.
Yeah, I'm again, like if anyone asked me, like, what's the mission that you would like to see most, it would be Titan. Like that's always my first answer. So we're both Titan fans. It's a safe space here. But I would love to talk a bit about your experience. You also you're the founder of the Black and Astro community. So can you give just a quick introduction on that as well?
Yes, the Black and Astro community. I founded it last year due to police violence, social injustices upon Black and people of the African diaspora here in the US, in the UK, Africa, all over. So we're very global. And so we're celebrating our second year now, this coming Sunday. And we're not focusing on trauma, but this year we're focusing on celebrating us as a whole, as a community. So last year we wanted people to understand a little bit more about us and our struggles as being Black scientists, and how what a lot of folks don't understand is that we cannot separate the two entities. And so this year we're celebrating the two entities of being Black and being a scientist or engineer or a space or doing space policy or whatever it is that makes you a part of the Black and Astro community. And
if people, what's the way that you want people to get involved with what you're doing? What's the best way to participate?
Yeah, in order to participate, you can go to blackandastro.com. We will be celebrating so many different things. You can catch us on Twitter at blackandastro.com. You can catch us on Instagram and Facebook, and LinkedIn. So we're kind of all over. And we also have a YouTube channel.
Awesome. So, and if people want to follow the work that you're doing, where should they go?
So you can follow me on Twitter, Instagram at _astro_chick.
Perfect. Well, when you do find out what the haze is made of, will you let us know?
Absolutely. I'll
Awesome.
Probably be the first one yelling it from the rooftop.
I can't wait. Seriously, I'm so stoked on anything going to Titan. It's going to be great. Ashley, thank you so much for taking the time to chat with us today. Good luck with finding the answers to some of these questions. And like I said, let us know.
Thank you so much for having me.
All right, take care.
Bye.
All right, let's move on to the news portion of this week's episode. Alan, you're on my screen right now. So finally, Betelgeuse, solve it for us.
Okay, so let's get a bit of background here, because I'm sure we all need to be reminded about what was happening on Betelgeuse a year or two ago. Wasn't that well covered in the news? Who am I kidding? The great dimming of Betelgeuse was such a big, everyone was speculating. We all had our ideas. So just for background, Betelgeuse, as we know, I'm sure everybody here knows, the shoulder of Orion, bright orange star visible to the naked eye with bright color. It's a red giant. It's variable. Variable star observers have known for a long time it brightens and dims and so on. But towards the end of 2019, it started dimming dramatically, enough that it was obvious even to casual observers. You could step outside, just look up without all the work normally involved in variable star observations, and you could just see something's wrong. The star it's faded. And there was a lot of speculation as to what this could be. Let me check my notes here. Some of these things, I think what we all hoped for, was that this was an internal process. Something was changing on the star itself. It was dimming dramatically before it goes supernova, because it's overdue. We haven't had one in the Milky Way in 200-300 years now, I think. More. And supernova is in those final stages of its life cycle, where the next thing that happens is it goes boom. It's big, it's old, and we would have a lovely show. But we also know that this could be any time in the next 100,000 years, so I was holding thumbs, but we also knew it probably wasn't going to happen.
Yeah.
I can say that now afterwards. I'm pretty sure that it wasn't going to happen. Otherwise, it would have been something else. Perhaps something was passing in front of it. Maybe there was maybe there was a large planet that we hadn't discovered was obstructing the view, or perhaps there was something in our own solar system, a cloud of dust or gas or something in between us. Theories were all over the place. And of course, as we all know, I think the other popular theory was if you don't immediately find a complete scientific answer to a mystery, it must have been aliens.
Right.
Another alien megastructure, perhaps, right?
Yeah.
Which I think we could have a lot of fun pushing that idea, but you couldn't really take it too seriously. And I think the leading theory was dust, a large cloud of dust getting in the way. And well, I think that was pretty much settled towards the end, and now it's just been released. Astronomers working at VLT have confirmed that yes, it was in fact dust. Watching the whole process with the VLT, they were able to resolve the surface of the star. Not the sort of high resolution that I think the general public might have expected, but it's pretty amazing. I think that they can do that. And they tracked, yes, it was in fact a dust cloud passing over the surface. And the modeling of where this dust could have come from seems to be pretty consistent with what was observed.
So what do they think was the mechanism that happened now? That I'm assuming the dust came from the star.
Yeah. Well, not directly out of the star, but these stars, the reason it's variable in the first place is it's kind of unstable. It expands and it shrinks over time. And this is pretty standard for stars in this stage. And as they expand, the outer layers of that hot plasma gets ejected and lost into space. And over time, this forms what we call a planetary nebula. Mm-hmm. Because they kind of look like planets if you don't know what you're looking at through a small telescope, but nothing to do with planets beyond, well, they're around a star. But as this gas cools, it can begin to condense. The elements can start to combine and you end up with dust. And this is where most of the dust in the universe comes from. Stardust, right? The stuff that then goes on to seed nebulae, and when a star forms, this stuff can then condense to form planets and so on. So this is the mechanism that happened here. The most recent expulsion of material condensed, formed a cloud of dust, which then drifted in front of the star over the course of the various months. Was about 3 or 4 months, I think it was, maybe a little bit longer. And that's what they've confirmed. That's the dust condensed from the latest gas expulsion, obscured our view for a while, dimming it, and now it's gone.
So we always talk about this idea that it's always dust. That every time, every momentous discovery, literally in the history of humanity, like even when astronomers first tried to figure out where was the center of the Milky Way, and they thought that the sun was at the center of the Milky Way, turns out that they were just not able to understand the universe with all the dust around. There was, of course, the BICEP 2 experiment a couple of years ago, which had potentially detected the presence of primordial gravitational waves. There's Boyajian star, etc., etc. And every time it's always dust. But now we know what the dust is. And so this is the mechanism. You've got this situation where you've got these blobs on the surface of the star. The dust is being formed inside the star at incredible temperatures and pressures, and then making its way to the outside of the star and then being burped out into space and obscuring our view to the stars. So the conditions are right for the stuff to make it out there. And so I love this because we finally, we get to see this dust formation in action. This dust that has plagued astronomers forever. And here it is.
It sounds so mundane, dust on Earth. It just gets everywhere and it dirties your telescopes, and but you think about it, it's the end life of a star. It's of dying out, and then Carl Sagan is, we are all stardust. Now we've confirmed it. This is how it's happening.
Yeah, like when you look at a galaxy and you see those dark dust lanes, when you look at like a dark nebulae, that dust that's obscuring your view to what's going on inside the nebula, that's the stuff that's produced by stars like Betelgeuse in the end stages of their life and when they detonate a supernova. There's actually another mechanism. I just did a show about this, so I'm sort of kind of in my head. But when the star explodes as a supernova, it's already been releasing all this material, and then the energy wave blasts out, collides with this material that's already been expelled, and instantly shocks it into dust around the star as in this sort of expanding sphere outside of the star as exploded as a supernova. And so you kind of have these two main mechanisms, the Betelgeuse way right now, and then the future Betelgeuse way when it explodes. And that's all that dust is coming from these processes, which is amazing.
If Betelgeuse goes, it needs to go in Northern Hemisphere winter, because if it were to go in June right now, the sun would be almost in the way. So we wouldn't have as much of a show.
Yeah.
That's why it was kind of exciting when we thought something was happening in December. I was thinking in the back of my head, this is the perfect time for it to go, because it's right up there in the winter sky right now.
Yeah.
It's like, don't go in June or July.
Yeah. Yeah. Nobody gets to see it except for like a Martian rover.
I know.
Yeah. No, that would be unacceptable. I mean, fortunately, we do have a few telescopes now that could view it, but yeah. But
we want to see it like in the daytime.
Yeah,
like,
but Betelgeuse isn't going to be the one. It's there's probably stars that are more likely to explode. So
I think
Spike, or one of those.
Spike is one of the other nearby candidates too. That's within. It's out of the kill radius, of course, the 500 light year kill radius, but it's one of the other stars in the sky that's a good candidate for future supernova.
Andrew Planet is asking, what specific elements was this dust made out of? I don't think they said. Did they say exactly what minerals were detected?
No, I don't know. I think they're just able to see it visually, so
yeah,
I couldn't tell.
And Moya is the astronomer in the room. By all means, please stop me if I go down the wrong road here. Although you're not a stellar astronomer, so like, what do you know? But the so in the large stars like Betelgeuse, they're already up to the point that they're starting to use their fusion process has gone all the way up into silicon and some of those heavier elements. And so they're burping them out into the outer atmospheres of the star and then out into space. And so that's how you're getting these. So you're like, dust literally is like chunks of rock, but only
90
microns across. Just little collections of material. And so it's like, it can be heavier elements though. Silicon, oxygen, silicon oxides, things like that are being blasted. And I don't know exactly. Carbons, soot, things like
Irons.
that. Iron. Well, iron is like, you're getting pretty close to the end when you start to see iron. Yeah.
Exactly.
But in the supernova version, yeah, you're getting the iron. Yeah. So it's just like so our sun, as it nears the end of its life, is going to be throwing out helium, oxygen. That's about it.
Nitrogen,
right?
carbon, maybe.
Yeah, nitrogen, carbon, and then it'll run out of juice.
And we've talked about, Fraser, there's some controversy that went around a few years ago whether we're actually going to be a planetary nebula for the benefit of some future alien star party or not. So it's not a foregone conclusion that we will be. There's some controversy about that.
Yeah, but it's so weird because it's so great to see what is this just infernal problem that astronomers are always battling with, and yet it itself is such a fascinating idea, and to see the process in real time.
So dark matter is probably dust. Planet X is probably
dust. UFOs are probably dust.
UFOs are probably dust.
Yeah, exactly. Where did your socks go in the dryer? Probably dust.
It's dust.
Yeah, exactly. Awesome. All right. Thanks a lot. Dave, you got two stories. Let's do one first.
All right. China, in another uncharacteristic move of doing open PR, actually released some images this past weekend from their Zhurong rover on Mars in Utopia Planitia. This landed with the Tianwen-1 mission last month. And this was an all-in-one, very ambitious for a first mission for any nation. No nation has ever done an orbiter, lander, rover combo all at one crack. Zhurong looks a lot like Spirit and Opportunity and probably wins the award for the cutest rover out there, for those who like to anthropomorphize rovers. And what it did when it came down, it It came off the platform. It's very much like their Chang'e moon landers that they've been doing. It has a platform. The rover sits on top. It looks a lot like Spirit and Opportunity in a way, only it has a much cuter face than Spirit and Opportunity. And it went down and did a first where it deposited a camera on the surface, so a wireless camera, backed off, and got a pretty cool picture of the rover and the lander platform all in one frame. And I think there might have been some actual beyond PR, just some kind of looking at the rover to make sure everything was ship shape on it, so to kind of get a good survey of it. And they surveyed the landing site, and it was kind of nifty. They released it this past weekend.
I'm trying to get a bigger version. I'm going to try and show off a version here, but I need to find the one.
This rover is got a ground penetrating radar among some of its instruments on board, and they're going to use it to kind of ground truth that site as the orbiter is going overhead and surveying it, looking for subsurface ice and things like that. But it's been a pretty successful mission thus far. It's gone off without a hitch. China is the only, I don't really count there's some controversy about the Mars 3 Soviet mission that lasted like 30 seconds and returned a staticky picture back in 71. I kind of consider this the second successful nation to land on Mars behind NASA in the US. So China, and they have ambitions to do a sample return too, coming up toward the end of this decade. They may beat Perseverance because Perseverance is doing a very complex the beginning of a sample collection for a future sample return. We may have a third mission successful in the next Mars window in 2022, 2023, when the European Space Agency's Rosalind Franklin rover is going to Mars as well. So
the thing that's interesting that with this picture, and again, I'm going to try to, I don't even know where this goes. Where does that go? No, not there. All right, hold on. I need to try to think of a way that I can do this. I'm just going to put the picture.
I can attempt to screen share it if you want.
Yeah, I'm just going to put it in front of you. That should work.
That'll work.
Yeah, all right. Just put it in front of you. So, the picture. What's cool about this is, and my guests can't see what I'm doing, so I'm gonna make it so they can. Oh wait, can they? Yes. Sorry, everybody. I'm gonna have to do a little bit of magic here.
Yeah, we had never even seen this rover really very much before.
Okay. I know it's gonna be a little weird, Dave.
Mission. That's okay. I'm mirrored now.
All right. Can you guys see it now?
Yes, I can.
Okay. So what you're looking at, right? Obviously, there's the rover, the Zhurong, and then you got the Tianwen lander over on the right-hand side, and you're like, who took the picture? Right? And so they've got a little portable camera.
Yeah, they just dropped on the surface.
That they're able to set down and then use that to take pictures of of what they're working on. And I think it's I was talking with Pamela about this during Astronomy Cast. I think it's a really clever idea because it lets you, as a geologist, you can see the landscape and sort of understand what the rover is doing in perspective.
Yeah.
And I think that's just a really clever idea. Yeah, really impressive.
I'm curious if they're going to release any more how long that wireless camera is going to operate. We may well see more pictures from it. Yeah. And Zhurong, if it's anything like Spirit and Opportunity, it's got I believe 90 sols is what it's going to operate on Mars. But Spirit and Opportunity went way past warranty. Like they lasted many, many years. So yeah, Zhurong may go on for a while.
It's essentially a Spirit or Opportunity. It's got the solar panels.
It looks very much like it. Solar powered.
But with like it's golder.
It does look a little,
and the solar panels are sort of an interesting. Almost looks like butterfly wings a bit. So
yeah,
but it's got that same thing. It's got the sort of the two cameras to give it a perspective vision to be able to take images. And of course, the most important thing is that ground penetrating radar, which is the first time that's ever been deployed to the surface of Mars.
Yes.
The Chinese had incredible success with that on the moon to be able to probe the regolith down to tens of meters and really understand what it looks like beneath the surface. And now
Utopia Planitia is where Viking 2 landed in 77 as well. And the reason they picked that site is it's actually very flat. From a safety perspective, it was pretty likely they weren't going to land on a boulder or anything like that. So usually for your first landing, you want to go for safe instead of interesting as much as for a site. So now with Perseverance, like with NASA, and the technology's gotten better for it does its autonomous terrain avoidance coming into land. They can land in the more dangerous, like the big boulder fields, but it's geologically more interesting to explore kind of sites.
Now you mentioned a bit just like how sort of open and in real time we've been seeing this. How has it felt from your perspective as a journalist watching?
It's kind of interesting. Like I said, China is almost kind of a throwback to the old Soviet Union Cold War days, where it was like we heard the Soviet Union did a thing like a week later afterwards, where now they need to start being open with journalists and letting us interview people and answer questions and stuff. But it's China. There's a lot of a good follow is Andrew Jones on Twitter, because he specializes in a lot of times when I'm writing these, I'm scrolling through his Twitter feed to see what he's saying. So I'm like, there's a lot of observers of the Chinese space program that are out there trying to decipher. And there's what I think is really cool is there's amateur radio operators that are actually getting signals from Scott Tilley is one that, like, when they were doing their Mars sample return mission last year, he was the first source of information that we were getting that they were that he was seeing the Doppler shift, and he knew, okay, that the lander had separated from the module and things like that. And it's kind of interesting that amateur radio operators are monitoring all this as well.
Yeah, fantastic. Congratulations, China. Please keep us up to date on what you're doing. This is good for you, and it's good for us.
And talk to journalists.
Talk to journalists. Yeah, exactly. Let us see what's happening, even if bad things happen. All right, Moya, what do you got for us?
I have for you a paper published last week in the monthly notices of the Royal Astronomical Society, where they analyzed light curves from a giant star about 25,000 light years away from us in the direction of the galactic center. And they call it a blinking star. That's the categorization that they're giving it. It's a variable star, and you'll see why they call it blinking in a second. So it was discovered by the VVV survey, that stands for VISTA, and I love a nested acronym. VISTA variables in the Via Lactea, which is the Milky Way. But that part of the sky also overlaps with the OGLE survey, or the Optical Galactic Lensing Experiment.
Sorry, I got to stop you for 1 second. Sorry. Via Lactea.
Yeah.
Milky Way.
Milky Way.
I never thought that before. I didn't even realize that. I've seen Via Lactea before, but I was like, That's Latin, way, Milky Way. Oh my God.
Milky Way, exactly.
Okay, all right. Please continue. Sorry.
Okay. So the VVV survey is in the near infrared, and OGLE, being the Optical Galactic Lensing Experiment, is in the optical. These light curves of this variable star are really interesting because it's a dramatic dip. About 97% of the star's light is being blocked by something, or at least there's a 97% decrease in light. And the total transit, or this dip, from start to finish, lasted about 200 days. And this light curve is also, according to the paper, remarkably achromatic, which means it's colorless. It looks the same at different wavelengths. So whatever is blocking this light is opaque to different wavelengths.
I'm just going to take a stab in the dark here.
Yeah.
Dust?
Dust. No.
Oh. Okay.
No, it's not just dust.
Okay. All right.
Although I'm sure there is dust in the system.
Okay.
So the authors, they ran models of different possible scenarios, and they believe that it's a star that's about 100 times bigger than the sun, although it was unclear to me if they meant 100 times its radius or 100 times its mass. But about 100 times bigger. And the star is being occulted by a smaller companion that's about half of its size. And that small companion has an opaque disk around it, according to their models.
How?
How does it have a disk?
Well, so if you've got an object that is half the size of the star, and the star is bigger than the sun, and it's obscuring it from our perspective. Like, so that sounds like another star, and yet has an opaque disk around it.
Right.
Alien megastructure.
Alien.
I keep telling you guys.
Yeah, sorry. Yeah. So assuming it's not an alien megastructure, how do you get an opaque disk around a star?
That is one of the great questions that is left after reading this paper. I mean, like maybe some type of planetary or protoplanetary disk around one of these stars, but they're pretty massive. And it's unclear if a protoplanetary disk would survive that radiation coming off of such a massive star. But based on their models, the authors were able to rule out any intrinsic variability in the star that's creating this massive dip. And they ruled out the possibility that there's some occulting object that just happens to be passing by in the foreground. The star itself, the primary in this apparently binary system, is named VVV WIT 08. That WIT, W-I-T, is a miscellaneous category for variable stars that don't fit neatly into other classes, and it stands for, what is this?
That's amazing.
I know, I love that.
Yeah.
This is only the second observation of a star that appears to blink in exactly this way. So a massive luminosity drop off for a long duration caused by an occulting secondary surrounded by a disk. This is like a very specific type of system. This is the second example. The first was called Epsilon Aurigae. It's a binary pair on a 27-year orbit. The primary is an F-type star, and the secondary that's occulting it is a B-type star that has a disk around it. And 3 other examples of systems like this have been discovered since it was first observed in 2012.
That one's famous. Yeah, Epsilon Aurigae is famous among variable star observers.
Aurigae, nice.
Yeah,
got it. So there are 5 of them, but the authors expect that these types of systems are probably not uncommon. Like they expect there to be a lot more of them, but we just don't know much about how it happens, what that disk is.
Huh. And so like I'm imagining like you've got the one star and then it's in a binary system with another star that has some kind of protoplanetary disk around it, and the disk is at a bit of an angle, and so it's passing in front of the star and kind of partly obscuring it. But the star is obscured as well. So whatever this thing is, you can't see. Like if you had a star surrounded by a protoplanetary disk, you'd see the star, but you don't even see the star. There's just this. Got to go with Alan's hunch on this one. Yeah. You've got this alien megastructure.
Is that the official weekly space hangout hypothesis?
If Kimberly's not here, then we get to just wait a minute. You know, you're also an exoplanetary astronomer, so I know you don't want to be sort of tied to the idea that we're discovering that we've certainly discovered alien megastructures out around other worlds.
But I'm also a professional fictional world builder, and I love thinking about aliens. So
that's great.
This is a diagram from Burnham's Celestial Handbook for Epsilon Aurigae that like to have like a dust, like to have a secondary companion with a dust like torus around it. But yeah, that was a major mystery for years. Exactly what was going on, what was eclipsing this star every 30-something years or so. It's been notorious in variable star observing.
Yeah, these have really long orbits. They're like wide binaries. This one is every 27 years. There was another one that was every 69 years. Was one of the other examples. So,
really cool.
Cool systems.
And I love that designation, the WIT, like the what is this? And
that is cool. I'd never heard of that.
Yeah, no, I hadn't heard that before. And so you think about like when these new telescopes come online, like when, say, Vera Rubin comes online, there's going to be tons and tons of these kinds of objects that are just like brand new mysteries. It's going to be a whole new
Epsilon Aurigae dimmed, I think, last in 2008, 2009. You can see it with the naked eye. You can see the difference. That's what's kind of cool about it. It's a naked eye star.
Yeah, that's really cool. Awesome. All right, Dave, you had one more story for us. Yes, speaking of things that can be seen with the naked eye.
Naked eye. Well, this was naked eye. Now it's not quite, but it may come back again. This past weekend, we had an alert notice come out that it was a Japanese amateur astronomer that discovered a new galactic nova, as in a nova in our galaxy, as opposed to a supernova seen in another galaxy in the constellation Hercules. Now, this is very close to the border of Aquila the Eagle right now, but it's actually placed well in the evening sky for Northern Hemisphere observers. And he discovered it at 8th magnitude. It topped out Sunday, which was only a day after discovery. So that's quite fast. It topped out at 5.5, magnitude 5.5. So from a dark site, this was naked eye very briefly, still very respectable down about 9th magnitude. I noticed from some photographs, it's very near a famous asterism that we've looked at in the virtual star party before called the coat hanger. And that's something when you're scanning down along the plane of the Milky Way that a lot of people notice, hey, there's a group of stars that look like a coat hanger there in Aquila very nearby. So that's kind of a good finder post for it. This looks to be my back of the envelope calculations for it was roughly about 20,000 light years distant in the Sagittarius arm. I wrote a brief post about it. I was traveling right as this happened. I mean, like in transit. So when I read about it that day, I was like, darn, I can't write about this right now. But as soon as I get near Wi-Fi, which was today, so it's like I wrote up a brief article on Universe Today, put the finder charts out. We get these we had one recently, usually every few years, we get a naked eye nova in our galaxy. We had one in Cassiopeia earlier. It was a binocular one. It was knocking on 6th or 7th magnitude. Probably the last good one we had was in 2013. We had one in Delphinus the dolphin. That did get up around 2nd magnitude. And it's kind of cool when you get those kind of novae, because then it kind of changes the shape of the constellation for a time, that you actually have an extra star. About once a decade, we get a naked eye one, and we've had novae come up as far as plus 1st magnitude, which is pretty respectable. Even from an urban site like where I observe from, you would be able to see this. So let's hope. I'm monitoring this one on the AAVSO, the American Association of Variable Star Observers, has a very good website that shows all the recent observations. I'm checking every day. Yes. And I'm looking, there is a possibility it could flare up again. Novae have been notorious for brightening, then dimming, then brightening again. So we'll see. It could be dust. So we'll see. It might brighten up.
It's I always love to imagine in my mind what's actually going on, where you've got this nova, you've got some white dwarf that's feeding on some
Sucking
companion
material.
star, and materials building up like a spare tire around the belly of the white dwarf, and then it gets enough material and it ignites for a moment. It's like the center of a star, but on the outside of the star, and it burns off, and then it all happens again.
There are a handful, less than a dozen are known, of notorious class of variable known as recurrent novae that do this over and over again on irregular intervals, 10 years, 20 years. Euscorpii is a famous one. T. Pixidus is a notorious one too, that will, I have a table of recurrent novae in my new book, so it's like to plug my new book. So
nice.
It's those are always neat to follow.
And then it's eventually, at some point in the distant future, it will have gobbled its last meal, and it will cross the Chandrasekhar limit and explode as a Type 1a supernova. And alien astronomers will then use the Milky Way to calculate
the distance,
the distance and the expansion of dark energy. So it's one of those circle of life kind of things. All right. Well, Dave, you're on my screen, so why don't you let people know what you're working on and where they can find out more?
Yes, I'm at AstroGuys with a Z on Twitter, and I'm frequent contributor to Universe Today, Sky and Telescope, Astronomy Gear Today. I also have my first published book with Universe Today, and I have my second book came out last year. This one is all deep sky objects, and this is a field guide of everything northern and southern hemisphere. And I am currently monitoring the Chinese crewed launch, the taikonaut launch. I know it's controversial to use that. Some people don't like the astronaut taikonaut term, but I use it. But for going to their space station coming up. And I'll be tracking that too. Once they launch, usually what I'm doing is seeing where you get visuals, because you can see their space station with the naked eye, their Tianhe core module. So you should see, I don't know when Shenzhou 12 is docking, but you should see the two as two tiny stars if you have a pass of their space station coming up.
Awesome. All right, Moya.
You can find me on Twitter at GoAstroMo. Right now, these days, I'm writing a book. So today, I wrote a love letter from the Milky Way to Andromeda, because the book is about the Milky Way, but told from its perspective. And I host a podcast called Exolore. It's EXOLORE. Tomorrow, I have a really exciting episode coming out, imagining a world where the night sky is always changing from year to year. And I built that world with a really cool arachnologist. So check it out. It was fun.
Wait, what's an arachnologist?
An arachnologist is someone who studies arachnids. She specializes in scorpions. And so the life form we imagined was like an intelligent spider-ish species.
So it's exactly what I thought it would be, like someone who studies changing night skies, and there's no reason why it's arachnologist. Okay, fine. Got it.
I'm the person who studies changing night skies.
Right. Yeah, okay. All right, and Alan.
Yeah, well, you can find me on Twitter as well, at @astronomer. I have not been up to very much astronomically recently, just moving homes and changing jobs and what have you, but I now live somewhere where I can see the sky.
What?
So I'm going to blow the dust off my telescope, and that'll probably inspire me to finish this season of the Urban Astronomer podcast, which has been stuck for a while, and I've been getting a bit of flack about that. So I owe you guys an episode, and it's coming soon. I do have material recorded, so wish me luck.
Good luck. And of course, I'm Universe Today on all the things. I just posted my new QA, which included a bunch of information on space dust, which is why that was all in my head. I've got an interview next week, which I will post on the calendar shortly. And of course, everything is, Universe Today is going to keep happening over the summertime, but all of my live streams will be wrapping up in another 2 weeks. And speaking of that, next week will be the penultimate episode. So we have one final guest next week, and then we're going to have a big hangout with everybody who wants to show up. I have no idea what's going to happen and how this is going to work. It sounds like a mess, but it's going to be fun.
No, it's going to be fun.
Yeah. But we'll do that. All right, I'm going to put everybody back up on the screen. There they all are. Thank you, everybody, for joining us this week on the Weekly Space Hangout. We really appreciate having you hang out with us. Thanks to all of my co-hosts for bringing the space news, to our special guest. And thanks to everyone both on YouTube and on Twitch if you're out there. And a special thanks, as always, to the moderators and Nancy Graziano for keeping everything so organized. We could not do this without you, and we appreciate you, Nancy. Enjoy your holiday as it comes in just a couple of weeks. All right, thanks, everyone, and we'll see you all next week. And press the button. Did it.